All right, everybody, welcome back from spring break. I hope that you enjoyed some time off from school and maybe you got a chance to just relax and rest a little bit. I hope that you did. We're in sort of a strange time, but we're going to begin learning math online and see how things go. So first off, I just want to make sure that if you have any questions or concerns or anything going on that you want to let me know, please email me and let me know what's going on. I hope everybody's well and that your families are good and things are going okay. So feel free to check in and just tell me what's up. Let me know if you have any questions regarding Canvas or anything else. Okay, so we're going to jump in to this new unit. I haven't yet prepared the tools to help you retake the Unit 15 quiz or anything like that. I honestly haven't even scored them yet. I'm sorry. I thought I'd have time to do that yesterday or today, but it's been hectic with meetings and getting other stuff ready. So as soon as I get that ready to go, I'll post about it in Canvas so that people can do whatever they need to. I know some were quite concerned about it, but I haven't scored them yet to even see how people did. Okay, this is quite a packed lesson, so the video may be long, but feel free to fast forward to the parts that are interesting to you, or watch it at a faster speed if you want to, or feel free to slow it down and devour it piece by piece if you want. So let's start with this triangle angle sum theory. So the sum of the measures of the angles of a triangle is 180 degrees. I think that is something that a lot of people are just kind of familiar with, but I also thought it would be useful to try to prove why this occurs. Okay, so we're going to pretend, as we so often do, that I was able to draw a couple of parallel lines right here, okay? They don't look perfect, I know, but we're just going to pretend that they're all good. So we've said that when two parallel lines are cut by a transversal, then we have some cool relationships, right? So this measure right here, that angle right there, is an alternate interior angle to angle A. So whatever angle measure we got for angle A, we would have the same one for that angle up there, right? And likewise, if we think about this transversal through our two parallel lines, we also have an alternate interior angle right here with C, right? And you may notice that all together they are making a straight line. So that's one way to prove, based on what we've got, that these three angles together add up to equal 180 degrees. If we were in the class, I would have you take a piece of paper and cut it into the shape of a triangle. You could pick whatever you want. So say that you cut it like that. You've got yourself a triangle. Then I would say to label each of the angles. So you would put like a 1, 2, and 3 in there. And then I would have you tear off each of the angles, like just taking, whoops, that's way bigger than I wanted it to be. This, you just tear there, tear that angle, and then you would put their points all together. Put all of their points together, and they will line up together like that, sort of, 1, 2, and 3, to make a straight line. So that's sort of another, like a physical proof to prove to us that all the angles in a triangle, all three angles of a triangle, will add up to equal 180 degrees. So we're going to use that information now to do some fun math. So for instance, on this one, we've put two triangles together, and they want us to see if we can figure out some of the information here. So at a glance, the big triangle, I have two of the angles, and I could find the third angle, but they've cut it into parts, and they didn't tell me it was bisected, so I don't know if they're congruent to each other or anything like that. If I look at this triangle, they've given one of the angles, but the other two are unknown, so that's not enough. But this triangle here on the left, they've given us two of the angles, so we can find the third one, right? If we take 180 minus 66 and minus 84, we would find that the remaining angle is 30 degrees. So the measure of angle 1 is 30. Now we could take the big triangle, right? So we know 43 degrees over here, 66 degrees over here. These two together have to add up to equal something so that when we add all three angles together, we get 180. So do you know what the measure of this big one at the top should be? It should be 71, right? But since this part is 30 degrees, then the measure of angle 2 is 41 degrees. I hope that made sense. Okay, and now we have enough that we can find the measure of angle 3, right? We've got these two angles, and if we add 41 and 43 together, that would give us 84. If you take 180 minus 84, that would leave us with 96 degrees for this third angle. Yeah. Okay, let's look at example 2. I want you to maybe pause for a second, see if you can solve this one on your own. What we know about this is one of the angles is 90 degrees. And if I add up all three angles, it should equal 180. So I could do 3x minus 5 plus 7x plus 5 plus 90 altogether has to equal 180 degrees. Sorry, it's imperfect writing there. So that gives us 10x plus 90 equals 180. Subtract 90 from both sides, divide by 10, and we would find that x ends up being 9. And I think it's, if you want, you could plug it in, make sure that you solve each of these to get an answer that seems accurate. If you add all that, it should equal 180. Okay, so concept number 1, done. I didn't know if this would be too much to take at once, so I have included some worksheets for you to just practice with this information to see if you can figure out the missing pieces of anything that's there. That one seems kind of interesting. I like it. So anyway, if you want to practice this skill a little bit, that's what these pages are for. You don't have to turn it in. It's not part of an assignment. But, it's worth trying maybe at least the last, 3 or 4. They start to get kind of hard. So if you start at problem 7 and it feels too tricky, scooch back to 1, 2, or whatever, but give those a shot. Anyway, that's the general concept from triangle angle sum theorem. Next we have this exterior angle theorem. Okay, so what I want us to think about on this one is suppose that I called this angle 4. Then I know that if I add it up to the measure of, maybe that math language is important here, the measure of angle 2 plus the measure of angle 3 plus the measure of angle 4, that would all equal 180 degrees, right? That's what our previous little bit just told us. So then we also have a cool relationship here. These two are a linear pair, right? So now I know that the measure of angle 1 plus the measure of angle 4 is 180 degrees. That was the neighbor's dog barking, if you heard that sound. What I could do is set these two, I could use transitive property, since they both equal 180 degrees, and set these things equal to each other. Let's go ahead and do that and see what we have. So this doesn't go with this example. I'm just going to use this space to write. So we would have the measure of angle 2 plus the measure of angle 3 plus the measure of angle 4 equals the measure of angle 1 plus the measure of angle 4. See where that came from, transitive property there. If I subtract the measure of angle 4 from both sides, I'm left with the measure of angle 2 plus the measure of angle 3 equals the measure of angle 1. And that's the whole point of this exterior angle theorem. So if you have an angle that's formed by a line continuing from the triangle, and it's on the outside of the triangle, so exterior angle, hopefully that name's starting to make some sense, it is equal to the sum of the other two angles. Kind of cool, right? Now, I have to be honest, for me, that doesn't just 100% come to mind, but I can look at the picture and kind of intuitively figure that out because I can see that these three have to be 180, these two have to be 180, since they both include 4, and then they're supplementary to whatever else. It makes sense to me that those would have to be congruent to each other. So if you want to pause and think about that for a minute, you can. I've included a page that has some practice of this. It's called the B page. So if you want to look over at the 16.1b problems, this will give you a chance to practice that idea a little bit more, become familiar with it. I've included the answers there too so that you can check and see if you're on the right track. So again, those are just practice problems to kind of help build up your confidence. Let's take a look at example 3 here. And of course, feel free to pause the video and look at what you need to as you move along, okay? Okay, here we have an exterior angle, this one, outside of that, and we don't have this angle, but that's okay. We don't need it because we just discovered that these two angles added together equal that exterior angle, right? The 3 angles inside the triangle would have to add up to be 180, and those 2 would have to add up to be 180. Since they're both missing the same key part, they have to equal each other. So we can solve this by saying, okay, 4x plus 13 plus 6x plus 2 has to equal 4x minus 13. So I'm going to combine like terms on the left. And then as you go ahead and finish solving this, we would discover that x equals 7. If I plug it in, because I like doing that to see if it really worked out like I thought, I would get 44 degrees for this inside one. Maybe I should have written it inside. And 41 degrees on that other one. And then this external angle would be 85 degrees. So their sum should work. Now, do we have enough information that we could figure out that missing angle? Yes, right? It should be 95. Oh my goodness, having trouble writing there. Okay. So anyway, good information. Now they throw in a little bit of math language for us to figure out the problem. So this is good stuff. It says, if the measure of, in triangle JKL, so it may be a good idea to draw a picture of your triangle. One of the vertices is J, one is K, one is L. Okay. If angle K is 9 more than angle J, I'm going to go ahead and call angle J little j. If angle K is 9 more than that, then that's the same as J plus 9, isn't it? Angle K is 9 more than the measure of angle J, and the measure of angle L is 21 less than twice the measure of angle J. Ooh, I messed this one up when I was doing it on my own. I forgot the twice part. So 21 less than twice the measure of angle J. Find the measure of each angle. Okay, do we have enough information to figure out what J is? And then once we find J, find the others. Yes, if we add all 3 of these things together, all 3 of those angles, since they're all inside of the triangle, they should equal 180 degrees. So this one's actually using that triangle angle sum theorem, right? Rather than exterior angle, but whatever. Okay, so combine like terms, we'd get 4j minus 12, I think. Let me double check just because I would hate to be wrong while everybody's watching. Yeah, negative 12 equals 180. Then we could add 12 to both sides and divide by 4. What have I done? I've done something wrong. 192 divided by 4 is giving us 48. So is J 48 degrees. And that would mean that K is 48 plus 9, which is 57 degrees. And that angle L is 2 times J, which is 48. 2 times 48 minus 21. That one ends up being 75 degrees. And let me just double check that if I add all those together, they do equal 180. That seems like it works. Whew. When I tried that on my own, I totally missed that twice thing. And I ended up with answers that worked as well, but obviously we're wrong. Okay, that's the second content piece, exterior angle theorem. Okay, moving on now to this, and I sort of hate that it's in this place because we don't have a good proof for this just because we don't have the skills, we haven't built our geometry enough to get it. So you're just going to have to, I'm afraid, take my word for it at this point, and then later on I'll be able to prove it for you, which is very backwards in geometry. So I'm really sorry that's what's happening here. This is a vocabulary box. So lots of good vocab for you to see in here. It says that this is an isosceles triangle. Isosceles triangles have two sides congruent. And those two sides that are congruent are called legs. So this one is a leg and that one is a leg. The angle where the legs intersect is called the vertex angle. So they meet at this point B. Angle 1 then is the vertex angle. The side opposite the vertex angle. So if we go and look at the side that is across from, opposite of that angle, this side is called the base. And the angles along the base, like this one and this one, those are called base angles. So everything has a name. But you'll notice that we have some duplicate names sometimes. That's supposed to say base angles. Sorry about that writing. Okay, so we have some words that show up a couple of times, right? We have leg showed up twice, and base angles showed up twice, and there is only one base and only one vertex angle. So those are the standouts on their own. Okay, a couple of cool things that, like I say, I can't prove, but I can tell you about, and I think that you can intuitively take them. If two sides of a triangle are congruent, then it's isosceles, then the angles opposite those sides are congruent. So they're saying if you have a triangle with congruent sides, then the angles that are across from those sides, so like here's a cross, those angles are congruent. Okay, so in our picture, angles 2 and 3 are congruent. Our picture up above. Okay, and the converse is true. If two angles of a triangle are congruent, so if they told us right off the bat that these two angles were congruent, we could use that information to then know that the sides opposite them are congruent. So we could have said that AB is congruent to BC. And I'm just putting them in alphabetical order. It doesn't really matter how we would say it, okay? So that's the converse. That's how those two things go. Lastly, we have equilateral triangles. So a triangle is equilateral if and only if it is equiangular. That's a fun word. That means equal angles. All three angles are the same measure. So this equals this equals this. Since we know that the sum of all of the interior angles of a triangle is 180, then what does the measure of each of these angles have to be? 180 divided by 3. It's got to be 60, right? 60 here, 60 there, 60 there. Every time we have an equilateral triangle, the measure of the angles, they are going to be 60, 60, 60. Okay, the thing it's asking for here is if the measure of angle A equals the measure of angle B equals the measure of angle C, if all those are equal to each other, then we know, gosh, sorry, it's hard for me to write without putting my hand on there, then we know that triangle ABC is equiangular. Sorry, I didn't Okay, and if the side lengths, if AB is equal to BC is equal to AC, if all the sides are the same length, then it's equilateral. Equi is the same, lateral meaning sides. Okay, so equilateral. I am not a weightlifter, and I should have verified this first, but if you do lateral raises, do they go to the side? If they do, that could be a way for you to remember that lateral is referring to sides in this. Equilateral is sides, equal sides. If it doesn't mean that, then I'm sorry. Hopefully you can remember it some other way then. Okay, we have two more examples. Sorry, this video is going long. So it says, if triangle RST is isosceles, find the measure of angle S. Since it's isosceles, and they told us that those two are the sides that are congruent, then we know that these base angles, the angles that are opposite those sides, are congruent as well. So we could find x by taking 15x minus 31 equal to 9x plus 11. And I already solved this one, and I found that x equals 7, so that if I plug it back in, this is 74 degrees, this is 74 degrees, and I think from there you can find the measure of angle S. It's 32 degrees. Okay. Example 6, they're giving us words and we've got to use the information they're giving us to figure out how to do this. So in triangle KLM, so I got to create said triangle. I don't know anything about it, so my picture might not be accurate, but it'll help me. If angle K is congruent to angle L, aha, we have an isosceles triangle at least, right? If those two angles are congruent, then I know that the side lengths opposite, so like this one and that one, they are congruent. So I'm going to go ahead and make that mark right off the bat. KL is 9x minus 40. That's according to the story. LM is 7x minus 37. And KM is 3x plus 23. Okay, find x and the measure of each side. So do you know how to attack this? Since we have this congruency marking, we know that those two sides are equal to each other. So we could say 7x minus 37 equals 3x plus 23. I'm going to run out of space here maybe. Sorry, that's supposed to be 3. And then we could solve and we would find that x equals 15. Then as you plug it in, you can find the measure of all the other sides. So will you take a second and do that? Pause the video and do it, and then check and see if you got the same answer as me. Okay guys, that's the end of this video. We're exploring how to turn in assignments through Canvas, so give it your best try, taking a look at, I also gave you a little bit of practice, 16.1c. Has some practice with isosceles and equilateral triangles. They're a little bit easier than what you're going to see in the assignment, so I thought I'd include those just for you to try out. Go ahead and give the assignment a try, and if you get stuck or need any questions answered, shoot me an email, or I've put a discussion tab on there, and I'll be watching that, so you can put a question in the discussion and we can go over it together, or I could add a video of me going over some of the questions. So give this your best shot, see how it works out, and we'll try to move on. I think that I'm saying I want this due Friday, so do your best to get this turned in by Friday, March 27th. And up until then, I'm happy to answer some questions that you have on it. I'll have a new lesson and video for you to take a look at tomorrow. So we're just going to kind of keep plugging away. Please let me know if you have any questions or concerns. If you don't want to print out your assignment from Canvas, we are printing some packets that are available at the school. They're trying to keep people away from the school as much as possible, so So just know that if you can do it without, that's great. If you need or would prefer to have it printed out, they're there at the school. I would recommend maybe giving them a call. I've given the packet info to the secretaries, and they were printing it off for me, but I don't know if a lot of people are going to be there tomorrow because they're having people come pick up Chromebooks if they need it. So I think you've seen some emails about when people are allowed to go pick up the Chromebook or whatever. So you may want to keep that in mind if you're choosing to pick up the paper packet as well. Make sure you grab the packet that says honors. And it's huge. Don't feel overwhelmed. We're going to cut some of it. I just wanted to keep it all in case any of it is useful to us. Okay, see you guys.